Have you ever looked up at the night sky? Have you felt that sense of immense, quiet space? It stretches out further than our minds can easily grasp. For centuries, we have known the universe is vast, but in the last 100 years, we discovered something even more profound. The universe is not static. It is not just sitting there, silent and unchanging. It is growing. Every galaxy, every star, every distant point of light is moving away from every other. This cosmic expansion is one of the most fundamental discoveries in all of science. It reshaped our entire understanding of reality. This discovery, however, leads to a very natural question. It is a question that feels simple. It is a question you may have asked yourself. If the universe is expanding, what is it expanding into? It seems logical, doesn't it? When something grows, it must grow into an empty space that was already there. A balloon inflates into the air around it. Our intuition tells us there has to be something on the other side. There must be a void, an emptiness, that the universe is filling up. This question is not childish or naive. In fact, it is one of the most thoughtful questions we can ask about our cosmos. It is a question that scientists themselves have wrestled with for decades. It pushes us to the very edge of what we know and what we can even imagine. The answer is not as straightforward as our everyday experience suggests. It is more complex, more surprising, and in many ways, more beautiful. It requires us to gently set aside our familiar ideas of space and growth, and to embrace a new way of seeing the universe. We will use simple analogies to help us visualize these grand ideas. So, let's begin. What is the universe truly expanding into? One of the most common and helpful analogies for the expanding universe is that of an inflating balloon. Imagine you have a simple, uninflated balloon. Now take a marker and draw several small dots on its surface. These dots represent galaxies. Now, start to blow air into the balloon. Watch what happens to the dots. As you inflate the balloon, you will notice that the distance between every dot and every other dot increases. From the perspective of any single dot, all the other dots appear to be moving away from it. The dots that were already far away are moving away even faster than the ones that were nearby. It is not that the galaxies are flying through space. It is the fabric of space itself, the surface of the balloon, that is stretching and carrying the galaxies along with it for the ride. However, this is where we must be careful. The balloon itself is a three-dimensional object expanding into the three-dimensional space of the room. Our minds immediately see this and think, the room is the nothing the universe is expanding into. But for the analogy to work correctly, we must focus only on the two-dimensional surface of the balloon. The 20th century brought a revolution that completely overturned our understanding of space. It began with a thought experiment about light. Albert Einstein realized that space and time were not a static stage for the universe's events. Instead, he showed that space and time are interwoven into a single dynamic fabric, space-time. Einstein's equations revealed that the presence of matter and energy could warp and curve this fabric. This curvature is what we experience as gravity. The galaxies were not flying through a static, empty void. Instead, the very fabric of space-time itself was stretching. The galaxies were simply being carried along for the ride. It is about the fundamental grid of reality, the very meter stick of the cosmos, growing larger over time. Every meter of space is becoming slightly more than a meter with each passing moment. Therefore, the question, what is the universe expanding into, is based on a flawed premise. It assumes space is a passive container. But if space is the very thing that is doing the expanding, the question is like asking, when you grow taller, what is your height growing into? So, we return to our original, intuitive question. Is the universe expanding into anything? The direct answer, according to our standard models of cosmology, is no. The universe is not believed to be expanding into a pre-existing empty space. To grasp this, we must be very clear about what we mean by the universe. The first is the observable universe. This is the portion of the cosmos from which light has had enough time to reach us since the Big Bang. The second meaning is the entire universe. This refers to the totality of existence, including all the space and galaxies that lie beyond our observable horizon. If you could magically transport to the edge of our observable universe, you would find yourself in a perfectly ordinary region of space, with a whole new cosmic horizon. This brings us to two main possibilities for the entire universe. The first is that the universe is infinite and flat. If the universe is infinite, it does not need to expand into anything. An infinite expanse can stretch and grow without requiring an outside container. There is no edge, and therefore no beyond. But what if the universe is not infinite? The second possibility is a finite but unbounded universe. Think of the balloon surface again. Our universe could be the 3D equivalent. A spaceship could go straight and eventually come back from the other side. The universe would have a finite total volume, and still, there would be no boundary. In either case, the conclusion is the same. The universe does not need an outside to expand. Expansion is a change in the geometry of space itself. After this journey, you might be left with a lingering sense of dissatisfaction. The answers can feel abstract and elusive. This feeling is completely normal. It stems from the fact that our minds are not built to comprehend reality on a cosmic scale. Our intuition was forged here on Earth. These experiences taught us that space is a passive stage and that expansion requires an empty area to move into. When modern cosmology tells us that space itself is a dynamic entity, it directly contradicts this fundamental, hardwired understanding of the world. It does not just add to the map. It tells us that the map itself is the wrong kind of representation. It replaces the familiar concept of space as a container with the new concept of space-time as a dynamic fabric. The question itself remains a vibrant and active frontier of scientific inquiry. It pushes physicists to test the limits of general relativity, string theory, M-theory. These imagine our universe as a membrane, or brain, existing within a higher dimensional space. These are mathematical explorations into what might lie beyond our current models. The journey has transformed the question from a simple, "what's outside?" to a profound investigation into the fundamental nature of space, time, and dimensionality itself. The discomfort we feel is not a failure of understanding, but a sign of a mind stretching to accommodate a grander view of the cosmos. The answer may not be a simple picture that our minds can easily hold, but the act of asking is what fuels our exploration, always pushing the boundaries of our cosmic horizon.